This video will be our first Excel tutorial. The problem statement is to find the molar volume of N-pentane at 100 C in 1 bar. We're going to assume the Peng-Robinson equation of state holds for N-pentane at this temperature and pressure, and we have given parameters for A and B. So I'm going to show you how to do this in Excel. This is not the most elegant solution procedure, but it really does a good job of exploring the problem and showing you what's going on. I've got the Peng-Robinson equation of state over on the right-hand side as well. First thing that we'll need to do is some data entry. So I'm going to just simply restate the stuff that we have. We've got temperature and pressure, and it's going to be important to keep the units. Also, this is a tip. If you want to type the degree sign nicely on Windows, you type Alt 0176, and that'll give you the degree sign. So T is 100 C, P is 1 bar. I'm going to need the gas constant at some point, and I'm given units for A and B, so I want to look up the value of the gas constant that is going to be consistent with those units. So a gas constant of 83.14 is going to be in units of bar, centimeters cubed, and I'm not going to be picky about the formatting here, and moles and Kelvin. All right, so just reminding myself what the units are is a good practice. Okay, and volume is the thing that I obviously don't know quite yet. Oh, I want to type in my parameters for A and B. So when I need these numbers, it'll be helpful. So I'm just going to type equals 2.417 times 10 to the 7, and B is equal to 90.18. And I'm going to also put my units in here. Divided by moles squared, centimeters cubed, divided by mole. All right, I'm ready to start. Actually, I'm not ready to start quite yet because I have my temperature in degrees C. Remember, for any equation of state, you always want absolute temperature. So in order to convert this to Kelvin, I'm going to say equals 100 plus 273, and if I want to be picky, I'll say 0.15 and do some more significant figures. And I'll change the unit from Celsius to Kelvin such that I've got consistent units. Okay, now in a cell, I may be tempted to just say V. And also a side note, all these V's should be V underbars. It's just hard to format that in a computer. So just understand that any V here is molar volume for Excel purposes. I'm asked to find the volume, and because Peng-Robinson is a cubic equation of state, it's not quite so easy to solve for V, given what P and T are. But I could solve for P relatively easy because the equation is already solved for P. So instead of solving for V, perhaps the most rudimentary thing to do would be to use a guess and check procedure, where instead I'm going to set a value of V. So I have to make an initial guess. And my volume here looks like it would be in centimeters cubed per mole. The problem with this is that I really have no real basis for what I should choose. I guess the only thing that I have is the parameter B. Remember, that is like the minimum volume that just the molecules take up. So I know that my V has to be greater than B at least. So let's try 150 centimeters cubed per mole. That would enable me to then calculate what P is. So I'll say this is P calculated. And I'll say that P has to be equal to R times T divided by V minus B. So note where I'm putting parentheses in Excel. In the denominator, they're especially important. Minus the parameter A divided by, open parentheses, V squared minus 2 times, also in Excel, remember you always have to have multiplication syntax, times B times V minus B squared. All right, and this gives me a pressure calculated of 2423, What are the units of that? It should be bar. Let me just go through and double check that really quick. And it makes sense that it's bar because R is in bar centimeters cubed per mole per Kelvin. So multiplying by T gets rid of the Kelvin, divided by volume gets rid of the centimeters cubed per mole. Now I can compare this value of P to my desired value of P and see that I'm way off right now. So I want to get to 1 bar and I'm at 2,423 bar. That's obviously not correct. And maybe that makes sense because I chose a very low value of V. So remember, if I choose a higher value of V, then my pressure should go down. So I might continue on in this fashion, guessing and checking. Oh, I got a negative pressure. That's weird. I wonder why that is. We'll see that in a moment. So think to yourself, can pressure ever be negative? That doesn't really make a whole lot of sense. Maybe 500, still negative. That can't be. So let's keep going. And I can continue guessing and checking in this manner. Let's try 2,500. I'm going lower a little bit. And you can see that this is going to be a lengthy process. Maybe not. Maybe I could get there with a couple more keystrokes. So while this works, it's definitely not optimal because it's going to be probably more time consuming, and it also doesn't give us any intuition about the shape of the curve or the shape of the behavior. In other words, there's no explanation for why there's a negative. I don't really have any sort of intuition about what the answer should be. So I'm going to show you a slightly different way that's a little bit better, I think, in my opinion. And that is going to be plotting the pressure versus the volume. So in Excel, again, I'm going to do this over here. I'm going to make 2 columns, one for volume and then one for pressure. And I'm going to plot multiple values of volume. So I already know that the minimum volume is going to be 90. So I'm going to start maybe at, let's start a little bit higher. Let's start at the 150. And then let's add 100 every time. So I'm going to put 150 in my first column. And then this is just a personal preference thing of mine. Whoops. I like to make it so that my cells are centered so that it looks nicely. Well, I kind of messed up the formatting there. Let's put that back. Okay, that looks a little bit better. So I'm going to put 150 there, and then I'm going to add 150. I'm going to add 150 every time. Let's see how that goes. So let's add this to the first cell, and then we'll copy this down for a while. And then maybe once the numbers get a little bit bigger, we'll start adding a little bit more. So let's now add 500 from here. Whoops. Forgot to push the plus sign. So I want a decent range of volumes here. And let's see. Yeah, I want to go to at least 12,000. Yeah, I want to go beyond 12,000. All right, so that's going to give me a good range of volumes, and now I need to calculate the pressure. So here I'm going to go ahead and copy this formula. Copy formula. But then you notice it says hashtag value. Why is that? And it's because I didn't have absolute references for this formula. So I have no dollar signs, in other words. So I can fix that. Just anytime I see, I'm going to have to move this quickly so I can drag my cell references. So G3 was R. I want to drag this over here and I want to dollar sign it. G1 was T. I want to drag that, dollar sign it. Perhaps you know how to do this already quickly. So I'm going to pause the video and then I'll show you at the end. All right, so just to review, anytime I'm referencing a parameter, in other words, P, R, A, and B, remember I'm solving for P in this formula, so P doesn't count here. Anytime I reference a parameter that stays constant, I'm going to double dollar sign it such that when I drag this formula down, those cell references stay constant. The only cell references that I do not have holding constant, so I've got cell F8 a couple of times, which is going to hold the value of my V. Because I'm going to drag that down, when I drag that down, this cell reference should update. So I'm going to hit enter, And then just on the lower right-hand corner here, I'm going to double click, and that's going to go all the way down. Now, if I pick a different value of P, you notice how the values of the parameters stay constant, but my value of V updates. And now look at all the values of P that I have solved for with respect to V. And now I can just look and see, okay, well, if I want to know where pressure is equal to 1 bar, I know that it's somewhere between 30,000 and 30,500. Another thing this allows me to do is I can plot this data. So if I highlight both columns and I go to Insert, Charts, and what kind of chart do I want? Typically scatter is the one that I want, but maybe a line, just a smooth line. All right, now a downside of Excel is that the default chart looks horrible. So also I'm not seeing the behavior that's really interesting. So I think my y-axis is far too large, and that's because the original value of V that I chose was so small. So I'm going to reduce that. I'm going to say I don't need to see all this stuff, and I want to rescale it such that I can see things more accurately. So I'm going to right-click on the axis and say Format Axis. It's going to bring up my Format Axis toolbar, and I'm going to set the maximum value to be, let's see, what do I want it to be? 200 maybe. And set the minimum value to something that's not quite so dramatic. Let's say minus 200. So negative pressures don't really make sense again. So it doesn't really matter what I choose here. I'm going to choose a little bit less, maybe minus 50. And then I still can't really see what I want to see. So let's say maximum is 50. Let's go a little bit less, 25. And a little bit less on the negative side, maybe minus 10. All right, now I've got some good behavior, and I can get a good sense for what the pressure looks like. I'm going to zoom in actually a little bit more. This is fun. I like being able to go in more detail. Okay, this looks pretty good. Now graphically, I can see that at 1 bar, I'm going to have 3 solutions for what the volume is. So if I just imagine that there is a horizontal line, let's see if I can draw. Where's draw? Shapes, lines. One bar is across like this. This is going to give me an intuitive sense for what my solution should be. So I'll show you in a second that you may get the solution that's over here, which these don't make any sense because of the stability criterion. So these pressures are not realistic. The pressure that we're going to be at is out here between 30,000 and 35,000. I'm sorry, no, it was 35. So in order to get the actual value, you should be looking at your actual numbers, not necessarily the graph. The graph just kind of gives you some context for the general behavior of the solution. Before I do that, I want to clean up this plot a little bit. So if you've ever talked to me, you know how bad I hate these default charts in Excel. I like to clean them up and make them look nice so that I can at least tell what I'm looking at. So I like to darken up the axes a little bit, make them black instead of gray. That absolutely has to be done. And then also I like to add axes titles such that I know what the variables I'm looking at. So you'd never want to turn in a graph that has unlabeled axes because your reader's not going to know what it's talking about. So I'm going to show you how to do that. Most of the things can be done inside this Format Axis window. So the paint icon will handle most of the aesthetics, and then any chart elements can be added by clicking this plus. So I want to add some axes titles. This is going to be my pressure, and adding units as well is a good practice. So I want to add in bar, and I have to add, oh, no, I already did. This axis is going to be molar volume in units of centimeters cubed per mole. And if I was turning this plot in, I'd want to go through in even more detail and make sure this cubed is raised and it looks nice, and my fonts are nice and dark and large. For the purposes of this video, I'm going to bite my tongue a little bit and not be so picky. All right, maybe I want to format the plot area, give a nice border on there, and make it look nice. Maybe these grid lines, or actually maybe I do want grid lines. I'm going to delete my line. Also add tick marks. So right click, format axis, tick marks, major axes type I'm going to cross, minor type I'm going to go inside. And you can change the units of these as well. This is going to make it easier to see where my one bar is. Maybe I want to add some more grid lines here. So I'm going to just regular click, add grid lines, and click the arrow. So I already have grid lines. I want to add primary, minor, horizontal grid lines. And I could darken these up a little bit if I wanted to as well. That doesn't look very good. I'm just going to go a little bit darker. There we go. So that adds some clutter, but at least makes it easier to tell where my one bar is. So this is still not a very aesthetically pleasing plot. The only reason I'm trying to show you that there's some options here where you can make it practical to see where your one bar is. And chart title, we don't need a chart title here. It's clear from looking at what the axes are. And I'm going to format this axis and say it is only going to go to 33,000. All right, so I know that my actual solution is going to be somewhere out in this area, but I don't know exactly what it is. Something weird happened there. I want to set my minimum to 0. There we go. All right, so how do we find what the actual answer is? I'm going to show you a couple more tools that you can use in Excel to solve equations. So like I said, this plotting exercise is maybe not the most elegant. However, it does give you a good sense for the general form of the data. In other words, if I change the problem around and I said, well, find the molar volume for which the pressure is 5 bar, you could then look at this plot and you could visually get a guess of what the molar volume is. I'm going to show you GoalSeek right now. GoalSeek is one of my favorites. Some other people may like Solver a little bit more. I'm going to show you both. So I'm going to go back to these cells where I was guessing and checking. And instead of guessing and checking my volumes, remember I could put whatever I want here, I'm going to GoalSeek by saying data, what if analysis, GoalSeek. So this is a way to iteratively solve solve an equation. So I'm going to set the cell and I have the value for P in that cell. So I want to set that cell to value 1 because I'm trying to find where the pressure is 1 bar by changing the variable cell of V. So what this does is it is guessing and checking, but the computer is guessing and checking many times faster than a human can. I'm going to hit OK. And it has found my exact solution. So 30,300 and so is what it says. I want to call your attention to something that is a potential pitfall, which is if your guess is somewhere else. So if my initial guess would have been 100 centimeters cubed per mole, and I go to GoalSeek and I say set that value to 1 by changing the value of V, then let's see what happens. Okay, now it gives me a different answer. Why did it do that? So P is still 1 bar, and that's because now it's giving me the answer that is over on the left-hand side. And this is not what we want. This volume is less than the volume taken up by the molecules. Volume is less than B. So when you're doing GoalSeek, your initial guess matters. And this is why it could be worth it to make the plot anyway, even if you are goal seeking, because it tells you that these answers are the ones that are not correct, that arise just because of the nature of how the curve was fit. So there's 2 answers that are out here, and then if my initial guess is closer to my actual answer, then it should give me the answer that I want. But if my initial guess is closer to the bogus answers, it's going to give me the bogus answers. So watch out for that. All right, next I'm going to show you Solver. So Solver is next to GoalSeek. I like to think of Solver as like GoalSeek's more sophisticated cousin. You may have to add in Solver in your Microsoft Excel. So if you don't see this Solver there, you want to go to your Files and Options and Add-ins somewhere. somewhere in this add-ins thing. I would recommend actually going to Google and just searching how to add in solver in Excel, and then they'll give you step-by-step instructions. So I'm going to make an initial guess that is, say, 500. I'm going to see what solver does. So I'm going to click solver. Already you see it's a little bit more sophisticated of a thing than GoalSeek is. Similar idea though. So I want to set the objective. I want cell B15 to the value of 1, and I'm going to change the variable cells of V. All right, so for this example, GoalSeek and solver are pretty much exactly the same. The idea is in solver you can add more constraints. You can solve for multiple cells at once. You can just do more things with solver, but because you could do more things, that also complicates things, and you have to know what you're doing a little bit more. All right, do I want to make unconstrained variables non-negative? Not necessarily. So uncheck that box. That box can screw things up very easily. Click solve. And let's see, it gave me the bogus answer again. So I have to watch out for that. So now I've got the third answer. So now I know what all 3 roots are. But again, so solver doesn't fix this either. Let's guess something like 10,000. And let's try solver again. Also, solver will save the last run that you did. So I don't have to go through and click everything in again. So hit solve, and there we are. We're back at our initial correct answer again. So this is how to use Microsoft Excel. It's one of my favorite softwares to use. Definitely not the most sophisticated software, but really helpful for arraying things and kind of getting a sense for solving the problem that you're trying to solve.